So we're going to start off going section by section. This is the June 2022 paper. This says convert this binary number into decimal, okay? Now, the easiest way to do this is to do 1, 1, 0, 1, 0, 1, 0, 0. And all you need to do is remember the place values of the binary, go along the top, 1, 2, 4, 8, 16, 32, 64, 128. Now, when you add 128 plus 64 plus 16 plus 4, that is equal to 212. So that's what you should have got for that answer. The next thing we've got is it wants you to convert this number into hexadecimal, and it wants you to show your working. Now, some people may add all the digits together here and then do division to get to their final answer, but what you need to do is you need to, if you want to do the easier way of doing this, what I tend to do is I go 1, 0, 1, 1, and I split it 1, 0, 0, 1. Then what I would do is I would work that out as 1, 2, 4, 8. That number is 9. 1, 2, 4, 8. So that's 8 plus 2 plus 1. That's 11. Now we know that this number is okay because we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it starts going A, B, C, D, E, F. So in this case, this number in hexadecimal, alright, so this would be if 10, remember if 10 is A, 11 is B. So this would be B, 9 as your final answer. Okay? If you want to make that clear, that is how you do that. Alright? Now, this question here, alright, wants to know the largest decimal number that can be represented using 6 bits. Alright? The best way for you to do it, if you ever get a question like that, it says the largest decimal number. Remember that we start counting from 0 when we're using bits. So what you've got to do is do 2 to the power of 6. What's 2 to the power of 6? It's 64, alright? But it says the largest decimal number, not the largest number of like outcomes. If it says how many possible outcomes, like when you're looking at colours and so on, yeah, you can get away with that. But it's the largest decimal number. We don't start counting from 0 when we're doing decimal numbers. We go 1, 2, 3, 4. So the largest decimal number you can represent is -1. So your answer should be 63. So don't get caught out on that. So if it is 8 bits, it would be 2 to the power of 8, and you would subtract 1 from it. But if it says the possible outcomes, you don't subtract the 1 from it. So just be careful of that question, not to get tricked up. Now we're going to do some binary addition here. So we've got 0 plus 0 plus 1 is 1. That's fairly straightforward, alright? 1 plus 1 is 0, carry the 1. Think about it. 1 plus 1 is 2. What's 2 in binary? 1, 0. 1, 2. Yeah? So, again, we've got 1 plus 1, which is 0, carry the 1. 0 plus 0 plus 0 plus the 1 is 1. 1 plus 1 is 0, carry the 1. We've got a problem this time. We've got the number 3. Think about how we represent the number 3 in binary. We would have 1, 1. So again, the same applies. We'd represent the number 3 here. So that is 1, carry the 1. Alright? So 0 plus 0 plus 0 is 1. 0 plus 1 plus 0 is 1. So your answer for that question, you'd get 1 mark for the first bit and the second bit. Usually when they do the mark schemes, they usually split them so you can at least get some of the marks, okay? Right. Moving on to a binary shift. Let me move this up a little bit. So that's right. So I've got this number here and it says shift it apply a binary shift 3 places to the right. That means you're going to lose 3 bits. Alright? The problem is here, a lot of people don't read the question properly, and it does say using 8 bits. So I can almost guarantee that some of you have got rid of these 3 off the end here, and have typed this in as your answer. So you've done a 3-digit shift. That's wrong. And you would not get the mark for that because it does say represent it using 8 bits. It's a simple thing. It doesn't show that you don't understand it, but what you should have done is pad it out this side to get the mark. So make sure you are padding it out this side. Now, it says state the arithmetic applying a left shift of 4 to a binary number. All right? What happens when we left shift once? It multiplies it by 2. So if we left shift again, that's multiplied by 2 again. If we left shift again. So what we end up eventually being is that the number that you started with is multiplied by 16. Alright? So think about it. If we go that way once, it's times by 2. That again is times by 2, which is 4. Times by 2 is 8. Again, then when we times that by 2, we get to the 16. Alright? So it is multiplied by 16. So remember, whenever we go this way, we multiply it by 2. Whenever we go this way, we divide it by 2. So if we go to the left, we multiply. If we go to the right, we divide. Try and avoid saying stuff like quartered and halved and stuff like that. Right? Just use the terms to show that you actually understand the division. Now it says, state the arithmetic effect of applying a left shift of 3 followed by a right shift. So what you've got to do, alright, so a left shift of 3, so if I went that way 3 times, alright, to this number, of the 5 to a binary number. So if you're dividing it, think about what you're doing. If I do a left shift of 3, alright, what's happening first? What's happening to the number? Pardon? I'm timesing it by 8, alright, because we obviously know a left shift is 16, so we've gone times by 8, alright, followed by a right shift of 5, alright. So what's going to end up happening? We're going to get rid of that 8 again, back to 0 basically, and we're going to be dividing twice. So what's it going to be divided by? Yeah. Divide by 4. Alright, so that would be the first section of that.